Instantaneous rate of change, again, is just another thing or direction that tells you to take a derivative. We are looking for the rate at which something is changing or something is moving at a particular time. It is just like finding the slope. A rate is like a slope. Rate of change is like a slope of a function at a given time. So if they ask for an instantaneous rate of change, it is just saying first derivative. It is just asking for the slope of the tangent. So if you see differentiate, find the first derivative, find the slope of the tangent, what is the instantaneous rate of change? All of those different things mean exactly the same thing. And it just means take your first derivative, plug in the value. So f prime of x here is low d high minus high d low over low low. And then I'm going to evaluate it at 1. So no different from what we've been doing. So I plug in 1 and I start to get some real numbers without variables in. So this would be -2 times 2 minus 1 times 1 over -2 squared. And again, that's just me plugging in 1. I get -4 minus 1 over 4, or -5/4. Final answer. That is the instantaneous rate of change. That is the derivative at x equals 1. That is the slope of the tangent at x equals 1. It is, again, all the same thing. We can go through these pretty quickly. Don't get yourself worked up about it. You do need to study the shortcuts, so you should be able to recognize which shortcut we're doing. If it's just a polynomial like number 2, then we just have to do our basic power rule. dy dx is -2x plus 2. Evaluate at x equals 2. And I just kind of put a nice easy one on there just to remind you that this sometimes can be a very quick process to go through. So that is -4 plus 2, or -2. That means the instantaneous rate of change is -2. That tells me that at this particular moment in time, this is going backwards or dropping, falling in a negative move, okay? Do not forget the chain rule. It seems like the chain rule is the one that people forget the most. I don't know why, but it's one that doesn't stick in our brains too much. So you maybe, again, study these rules, dy dx. I bring that 3 out front, leave the inner as is, lower the power 1, times the derivative of the inside. And again, my process after I find my derivative is to just plug in the number. dy dx at x equals 1 is 3 times 2 minus 1 plus 1 squared, 4 minus 1. I think it's 36. Looking for some agreement by somebody, if you will. And yeah, good. Okay, perfect. Again, all this is telling me is at this particular time, and this has a very huge application. I brought this up last week in physics when you were looking at time equals 1 second. What's going on with this whatever it is. It could be the stars, it could be a rocket ship, it could be whatever is moving. It's moving very fast in a forward direction. The review part of this, and I know this is not new, it's just got a different title, but way back, before we did chapter 10, when we started chapter 9, we talked about slopes, we talked about average rate of change. I just wanted to bring that up because I want to be able to compare the two of them, okay? What is the difference between the rate over a time period as opposed to the rate at an instant time, okay? So let's refresh our memory here. This is average rate of change. Average rate of change is just slope. Remember, you're using y2 minus y1 over x2 minus x1, or we sometimes refer to that as the change in y's over the change in x's, delta y over delta x. That's kind of dy dx a little bit, where that sort of connection comes between the two of them, average rate of change versus instantaneous rate of change. And so I need to not take the derivative when I'm doing the average rate of change, but instead I need 2 points. This is not a point. It is an interval. And we can interpret that differently. I am looking at x values that go from -3 up to -2. That's just another way of writing that interval. These are only the x values. And so in order to find my slope, in which I need an x and a y value, I need to input the x value and find the y value, or the output. And so I have to find 2 pieces of other information. What do I get when I plug in -3? And that's -1/5. And what do I get when I plug in -2? And that's -1/4. And so this is the point -3, -1/5, and the point -2, -1/4. And again, it's the change in x's, change in y's over change in x's. If I want to or need to, I can put it right into the slope equation. It would be -1/4 minus -1/5 over, bless you, -2 minus -3. The bottom math is easy. The top math, I might need to take out my calculator, especially if I'm not the greatest with fractions. Looks like -5/20 plus 4/20, or -1/20, I believe. Again, if anybody has an agreement for me, that would be lovely. Okay, good. Got some thumbs up. You're not just giving me the thumbs up just to make me move along, are you? You agree with me? Okay. All right. And so that is my average rate. Yes? What's that? So this would be -5/20 plus 4/20. Good. And then that's -2 plus, or yeah, -2 plus 3. Okay. So again, this is just a refresher on my average. And again, we can run through these problems fairly quickly, finding the slope. On the next page, we're actually going to compare the two. We're going to see an average over a given time and an instantaneous at a particular point. Okay, so this is f of -1 is -1 squared plus 1, or 2. F of 0 is 0 squared plus 1, or 1. The 2 points that I'm finding the average rate of change, or the slope, between are -1, 2, and 0, 1. And this is sometimes where I just do, when I don't have fractions involved, I'll just do my delta y over delta x, the change in y over change in x. And I think, how do I get from 2 to 1? I go back 1. How do I get from -1 to 0? I go up 1. That means my slope is -1. Again, that's 1 minus 2 over 0 minus -1 if you want to look at it in the slope formula. Okay? So let's finalize this by putting them together. We're going to do a couple problems where we find both the average and the instantaneous at a particular value, because to do the instantaneous I only need one piece of the interval. And so our directions are, for each problem, find the average rate of change over the interval, over the given interval. So the average over the given interval. So again, this is my slope over the given interval. And then the instantaneous at the leftmost value. Meaning I want to do the instantaneous at just the start of the interval. That's the leftmost value. This is my leftmost that I'll be using. Okay, that's what they mean by leftmost, the start of the interval. All right, so average. I'm going to do my average. I'm going to abbreviate that over here, average. Remember, I need to use the whole thing, so this is f of 0 gives me -1/2. That math was pretty easy. I didn't have too much of an issue doing that. The next one is not going to be as easy. F of 1/2. I'll have to do a little bit of calculating. That's 1 over 1/2 minus 2, which is 1 over -3/2, which is -2/3. So again, for my average, I have the point 0, -1/2, and I have the other point 1/2, -2/3. And when I find my change in y's over change in x's, I will do -2/3 minus -1/2 over 1/2 minus 0. -4/6 plus 3/6 gives me -1/6 over 1/2. And I believe that's -1/3 if I am remembering correctly, or doing my math correctly. Okay, so -1/3. Again, this is my average rate of change. Average is the slope. It requires 2 points. Now I'm going to do my instantaneous. That means first find the derivative. Low d high minus high d low over low, or -1 over x minus 2 quantity squared. Evaluate at the leftmost. If the interval is fairly close, like a fairly small interval, you should see similarities in your slope. If your interval is very long, or if your function is very active, you could get very different answers in your slope. It sort of depends on the function that you're looking at. But for the problems that we're doing, you should have an idea that you're kind of on the right track if your answers are fairly close to each other. Okay, they should be fairly similar, again, because we're not doing huge intervals. All right? I'm going to pause this, and I'm going to have you do the last two, and we'll compare our answers shortly, just to see if you get them. And then here's what I got for 8. Good? If there are not any questions, I'm not going to assign all of the reviews, so I'll tell you the problems that you should do for sure. So we can kind of go through that. Again, questions, or is everybody all right?